All right, guys, we're going to take another look at surface area today. Don't forget to put today's date in the top right corner of the notes. Today is March 22nd, and we are talking again about surface area. So, who can tell me what surface area is? How we define surface area? You, sir.
Number of square units number in a three-dimensional space.
Good. It is the number of square units needed to cover a 3D figure. Okay, we have a shorter name that we use for 3D figures. What do we call those? Solids. Okay, we also call 3D figures solids. Keep that in mind. So we want to find the surface area of this triangular prism. So first off, we're going to recognize what the capital B base would be on this triangular prism. Okay, and it would obviously be the triangles because it's a triangular prism. All right, so we outline them, lightly shade them in, and we label those as our capital B bases. Now, in order to find the surface area of a prism, we take 2 times the area of one of those bases plus the perimeter of one of those bases times how far apart those 2 bases are. So, using this formula, I'm going to need to find the area of one of those bases, the perimeter of one of those bases, and how far apart those bases are. So, let's start with the area of one of those bases. They're triangles. And what is that formula for area of the triangle? Area equals 1/2 times lowercase base times the height. So looking at this triangle, the base is along the bottom edge, and the height is the perpendicular distance from that lowercase base to the opposite peak. So what is the base? What's the lowercase base on that triangle? 8 centimeters. Okay, what about the height, the perpendicular distance from that lowercase base to the opposite corner? 10 centimeters. So let's take those pieces and let's sub those all in. Okay, what's that going to look like when we sub those in? Good. Okay, if we need a calculator, we can use one, but I don't think we do. What's 1/2 times 8?
4.
And what's 4 times 10?
40.
There we go. So the area of that base is going to be 40 square centimeters. Now keep in mind, what we found right there is not our final answer. Okay? This is just the area of one of those capital B bases. Okay, there's a little bit more work that we're going to have to do. Next thing we're going to need is the perimeter of that base. What is perimeter? How did we describe what perimeter is? How do we describe perimeter? The distance all the way around a figure. So how do I find that distance all the way around the figure?
Add up all the sides.
We add up all of the sides. Now I see on my diagram I'm missing something, and I look at your note sheet, I think you are as well. We're missing these side lengths on that triangle. Okay, so I'm going to give those to you now. Those are about 10.8. Okay, every single one of them is about 10.8 centimeters. So I want to write that in there. About 10.8 centimeters. So the perimeter for one of those triangles, I need to add up all of those side lengths. Now remember we said yesterday, the best way to make sure you don't miss anything is that put your pencil on one of the corners and trace around the shape, all the way back to where you start, and write down each distance. So if I start in this bottom left corner, and I go up to the top, that's 10.8 centimeters. Now from the top, back down to the bottom right corner, is another 10.8 centimeters. Bless you. Then across the bottom, from right to left, is 8 more centimeters. And if we need a calculator, we can use one. If I do 10.8 plus 10.8, that's going to give me 21.6. And if I add 8 to that, that's going to give me 29.6 centimeters. So we have the area of one of those bases. We have the perimeter of one of those capital B bases. The only thing I need left for my formula is how far apart those capital B bases are. Well, how far apart are they? They are 60 centimeters apart. So, I'm going to take all of those pieces and sub them into this formula. Okay, I have the 60 centimeters is how far apart. That's my height of the prism. I have the 29.6 centimeters. That's the perimeter of that capital B base. And I have the 40 square centimeters, which is the area of one of those triangles. So now we'll take all of those pieces and we'll sub them all in. And we'll have the surface area is equal to 2 times the area of one of those bases we said is 40 square centimeters, plus the perimeter of one of those bases we said is 29.6 centimeters, times the distance between those triangular bases is 60 centimeters. And we can use a calculator if we need to. 2 times 40 is going to be 80. 29.6 times 60 gives us 1,776. And if we add those together, we get 1,856 square centimeters. And this is a lot like the ones we looked at last time. A simple right prism. Any questions about this one? Okay. Well then, let's look at number 1 here. Okay, your number 2 is a little bit different than mine. That's okay. We'll straighten it out. Okay, number 1. We've got this goofy looking step deal. Okay? It's a little bit strange, but it's okay. Just like we were able to find the volume of composite solids, we can also find the surface area of composite solids. The only difference is we're going to use the exact same formula for these right prisms, the exact same one. So what we need to do is identify what our capital B bases are. So think about this. If I could take this shape off the paper, hold it in my hand and turn it around, which side would I set it down on so that the bottom and the top would be identical and it would stand straight up? Which sides would those be? What shape do those kind of look like? Yeah, you. Sorry? Well, not quite rectangles. Because the rectangles, the bottom side, this front, the back side, each one of those individual sides, they don't have an identical parallel side. What does have an identical? Not trapezoids either. You might be overthinking it a little bit. And not parallelograms either. Okay, guys, the shapes that we're going to use as our capital B bases are these L shapes. Okay, those L shapes are going to be our capital B bases. Now, like I said, It's going to be a little bit tricky. That's okay. Okay, so those are the sides that we're going to outline. Those are the ones that we're going to color in. All right, now, we're going to use that same formula. The surface area is equal to 2 times the area of one of those bases plus the perimeter of one of those bases times the distance between those two L-shaped bases. All right, so first off, let's take a look at this base. This goofy looking L-shaped base. If I need to find the area of this, what am I going to have to do? If I look at my formula sheet, I'm not going to find any kind of formula for the area of an L shape. So what do we have to do?
Split the shape up.
We're going to have to split it up. And I think this is what you guys were talking about when you were giving me parallelograms and trapezoids and rectangles. You were getting a step ahead of ourselves. You saw that these were going to be the sides we would use, and you were thinking about how to separate it. So that's exactly what we're going to do now. We're going to separate this into 2 separate rectangles. Okay, and there's a couple different ways that we could separate it, but I'm going to separate it into the big bottom rectangle and the smaller top rectangle. There's a couple other ways we can do it, but these are the ways that this is how I'm going to separate it here. So for the green rectangle, for the big bottom rectangle, area of a rectangle is length times width. So let's say length is here and width is along the bottom side to side. Okay? From top to bottom on that green rectangle, okay, that would be this distance. And this guy, or this guy, or this guy, or this guy. Okay, well I do have a number on one of them, and that's 3 centimeters. Then the width would be one of those measurements. Now be careful, because we might see this 4 centimeters right here and think, hey, that's the answer. That's what I need. But it's not. I need the total distance side to side, which is 7 centimeters. So the area of that green rectangle, 3 times 7, is going to be 21 square centimeters. Okay, then these blue rectangles. Okay, now for the blue rectangle, it's the same formula. Area equals length times width. Okay, let's think about length and width on that blue rectangle. What's the length on that blue rectangle? What's the length on that blue rectangle? It's 4 centimeters. Okay? What about the width? What about the width? 3 centimeters. And we can use a calculator if we need to, but that area is going to be 12 square centimeters. Now what we need to keep in mind is that these are 2 individual rectangles. They're 2 separate pieces. For the area of my base, of that L-shaped base, I need to add those 2 together. Okay, so to add those 2 together, 12 and 21, 33 square centimeters. Now what we just found here, guys, this is the area of that base. So when I take this, I will sub it in place of that capital B base. I'm also going to need the perimeter. I need the distance around that rectangle, around that L shape. So remember what we like to do. Pick a corner. Start at that corner and just trace around the shape, writing every distance. So if I start top left and I go across 3 centimeters, okay, go from that top right corner down and I have 4 centimeters. From this little corner out is another 4 centimeters. From this right corner down is 3 centimeters. Now across the bottom, side to side, okay, on this L, I don't have a number written here, but I can see it's going to be the same as this 7 on the front. And then up the back, okay, I don't have that on here either. But if I look at this shape, okay, I do know this part, and I do know this part. So I'll add them together, and how tall is the back? From here to here. It's going to be another 7 centimeters. Okay, and we can use a calculator if we need to. What do we get if we add those all together? What do we get if we add those all together? Good, 28. Yeah, 28. Now I have the perimeter. So I have the area of the base, I have the perimeter. The only thing left is I need the distance between those two L shapes. How far apart are those two L shapes? They are 8 centimeters apart. So let's take all of those pieces and let's sub them all in. So we'll have the surface area of this prism is equal to 2 times the area of the base, which we said is 33 square centimeters, plus the perimeter, which we found is 28 centimeters, times the distance between those bases, which we found was 8 centimeters. And we can go to a calculator if we need to. 2 times 33 is 66, plus 28 times 8 is 224. And if we add those together, what's the surface area of this entire prism? Good, 290 square centimeters. Now you stumbled a little bit and you wanted to say cubic centimeters. Why did you come back to square centimeters?
Because we're finding the area of the outside.
Excellent. We're finding area. Area of the outside is going to be measured in square centimeters. Volume gets measured in cubic centimeters. We're not talking volume, we're talking area. So we deal with square centimeters. All right, guys. What questions do you have on that one? What questions do you have on that one we just did? Nothing? Okay, what's tricky about it is that our capital B base is a composite two-dimensional figure. So that becomes a small problem within the much larger problem. Something that we have to work through. Find the area, we have to separate it into 2 pieces, find the area of each of those pieces, and then add them together to find the total area of that L-shaped base. Then we need to find the perimeter of that L-shaped base. Now that one's a little bit easier because that's just adding up all the sides. And then finally we need the distance between those 2 bases. And then, lastly, we can sub those into that surface area formula. Okay? All right, now on your page, you had a slightly different drawing for number 2, so I'm going to sketch that on here. You have this, and it's 10 centimeters here, and here is 5 centimeters. What shape is this? What shape is this?
A cylinder.
It's a cylinder. Okay? Now, if I had to, it's a little bit different than the prisms we've been working with. But if I had to pick capital B bases, if I had to pick this up off the board and hold it in my hand and turn it around, what would be the shape of the side I'd set it down on so that it stands upright and top and bottom are the same? Circles. Okay, these circles at the top and bottom of this drawing, those are going to be my capital B bases. So, I'll outline them. I will lightly shade them in. Okay, good. All right, now, for that base, for that capital B base. Whoop. Wrong tool there. Here we go. I have a circle. What's the formula for area of a circle? What's the formula for area of a circle? Good. Pi times the radius squared. What's a radius on a circle? Very good. From the center out to the edge. So what's the radius on this circle? 5 centimeters. So the area of that circle is pi times 5 squared. And we'll probably need a calculator because pi is one of those crazy decimals. But if I do pi times 5 squared, I should get something around 80. Something close to 80. What do you get? 540? Okay. So that's the area of that capital B base. So we can use that to find the surface area because we're going to use that same formula. Surface area is 2 times the area of the base plus the perimeter of that base times the distance between those bases. And what we just found here was which part? Which part of that formula did we just find? We found the area of that base. So we're going to be able to use this right here in place of that capital B base. Now we're also going to need the perimeter of that base. What do we call the perimeter of a circle? We call it circumference. And how do I find circumference on a circle? They actually have 2 different options. 2 pi times the radius. And that's the one we're going to use here. What was our other option that we could have used? Pi times diameter. But we're given radius instead of diameter, so we're going to use this formula. And we've already said the radius is 5. So the perimeter, which is actually the circumference of the circle, is equal to 2 pi times 5. And what's that perimeter? Truthfully, circumference. What's that going to be equal to? About. What'd you get? 31.416. Good. 31.416. Now guys, this is the perimeter of that base. The last thing that I still need is how far apart are those 2 circles? How far apart are those 2 circles? They are 10 centimeters apart. All right, now, let's take everything we have and let's sub it all in to this formula. And what's that going to look like when I sub everything that I have in here? I'm not asking for the final answer, just what does it look like when we put these numbers in place of those variables? Go ahead.
Surface area equals 2 times 78.540
Okay? And we can go to the calculators if we need to. Go ahead, use those calculators. And what did you get? 471.24. And what comes after the 4? Oh, just stop. Oh, right, because we rounded. Okay, good. All right, now, what are the units? 471.24 square centimeters. Remember, surface area is still area. Even though we're talking about a solid three-dimensional figure, we're only measuring the area of its surface. So we're going to stay with square centimeters. All right, guys, we looked at 3 different shapes. What questions do you have about any of those 3? Mm-hmm.
That only applies for number 1, right? Only number 1 is a right circle?
Actually, all 3 of them are right prisms. What it means for a prism to be a right prism is that you have these capital B bases, okay, like we have here and here. Okay, you have 2 identical parallel capital B bases. And what furthermore it means is that you can take those bases and you can set this figure up so that one of them's on the bottom and the other one will be directly above it on the top. Okay? A right prism basically means this, guys. You have this base along the bottom. You have an identical base up top. And you have all right angles between those sides. Between this side, that height, and that capital B base.
But what about number 2? What are the right angles on number 2?
So they would be between our capital B base here and this side.
On number 2.
Oh, sorry. Okay, they would be right here. Okay, between the edges, the sides, the height of that cylinder and that circular base. Okay, good question. Okay, so remember, the surface area is going to be equal to the area 2 times the area of one of those capital B bases plus the perimeter of one of those capital B bases times how far apart those capital B bases are.